Today we're going to be simplifying radicals. In order to simplify radicals, we must do prime factoring first. And prime factor is when we factor a number until it's broken down to a product of only prime numbers. So our first example is number 24. I'm going to use a prime factorization tree. So factors of 24 are 2 and 12. You could have used 4 and 6. And then we're going to keep breaking these numbers down until they are all prime. 2 is prime, 2 is prime, 6 is not. 2 times 3. So my prime factors of 24 are 2 times 2 times 2 times 3. Take your time to check to verify. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. For 27, I'm going to start out with two numbers that multiply together to be 27. 3 is prime, 9 is not. So you continue the prime factorization tree until you get all the way nothing but prime numbers. 3 times 3 is 9, 9 times 3 is 27. We want to do that because we're trying to find square roots today. If x squared is equal to y, then x is a square root of y. In the expression, the square root of 64, the symbol itself is called the radical. And the number 64 is called the radicand, the number up inside. There are some numbers that are what we call perfect squares. To find the square root of the following, we want to find the prime factors again. The prime factors of 4 would be 2 and 2. So I have 2 pairs of 2's. So the square root of 4 is 2. It is what we consider a perfect square. The square root of 25, 2 numbers that multiply together to be 25 are 5 and 5. So this is 5, but there's an invisible negative 1 here. So my answer is actually negative 5. Negative 1 times 5 is negative 5. 121, 11 times 11 is 121. So the square root of 121 is 11. It takes 2 to make 1. It takes 2 to make 1. Okay, what happens with those numbers that are not perfect squares? Not all numbers have an exact square root in its previous, as in the previous example. If a number is not a perfect square, then we might be able to simplify it. But simplifying does not mean decimals. Okay, so in order to do so, then number 1, find the prime factors, circle the pairs as we did before. 1 pair represents 1, and that will come on the outside of the radical sign. And the numbers left over will stay on the inside of the radical sign, and simplify. So in the square root of 8, I'm going to break it down, my factorization tree, to find my prime factors. 2 times 4, 2, and 4 becomes 2 times 2. So up under the radical, I have 2 times 2 times 2. In order for the number to come out of the radical, I must have a set of 2. So I have 2 2's. 2 would come out of my radical, and I have this 2 left over. It will stay on the inside of my radical. So the square root of 8 can be simplified to 2 times the square root of 2. No decimals. Same thing with square root of 20. So in the first find our prime factors. Square root of 20, maybe I started out with 4 times 5, and 4 becomes 2 times 2, and 5. So I have 2 times 2 times 5, which equals the square root of 20. In order to bring the number out, I must have a pair. So it says to circle your pairs. I have a pair of 2. That 2 is going to come out. The 5 is going to stay inside. 2 times the square root of 5 would be my answer. Okay. The square root of 72. Maybe I started out with 8 times 9, and then 8 became 2 times 4, 9 became 3 times 3. Remember to keep working your prime factorization tree until all of your numbers are prime. So inside of my radicand, I actually have 2 times 2 times 2 times 3 times 3. And it says to circle your pairs. I have a pair of 2s, I have a pair of 3. The 2 is going to come out and the 3 is going to come out. And because I have 2 of them, I'm going to multiply them together. So on the outside, I would have 6. And this 2 is left over to stay on the inside. 6 times the square root of 2. 6 times the square root of 2. Okay. If you would pause at this time and take a few moments to complete the your turn sections, number 1, number 2, and number 3, and then come back and check your answers. Okay, welcome back. Number 1 is 2. Number 2 is 2 times the square root of 6. And number 3 is 2 times the square root of 3. I hope you did a very good job in that section, and we will take questions on there if need be. Let's continue on. If you would please turn over, and let's talk about what happens when we have a negative number. Try to remind yourself, when you're taking the square root, we're looking for a number times itself. And remember that a positive times a positive is equal to a positive number. A negative times a negative is equal also to a positive number. So can I take the square root of -4? No, I cannot, because there's no 2 numbers that I can multiply together that would equal -4. Okay, the square root of negative times the square root of 25. The negative is on the outside. So that's like having a -1 times the square root of 25. So how do you find out the square root of 25? 5 times 5, I have a pair of 5s, that becomes 5 times the -1, making my answer -5. The cube root of -8, I'm going to go ahead and break down that 8, bring out that -1, so it's -1 times the cube root of 8. And 8 is a perfect cube, meaning I will not have anything left over. We're going to talk about this a little bit more in the section below, but I have 3 2's, so that 2 will come out. And we're going to multiply it by that -1 that was already out there, making my answer -2. Okay, the index of a cube is always 3. The index of a cube is always 3. So this is the index right here. It's numbered here. When you don't see a number there, it's the square root. So the cube root of 64 is written as the cube root of 64. You must have this 3 there in order to represent cube. If a number is a perfect cube, then you can find its cube root, meaning you're not going to have anything left over. There's no decimal, there's nothing up under the radical. So the cube root of 8, we looked at. 8 becomes 2 times 4, 2, and 4 becomes 2 times 2. In order to come out of the radical, we must have 3. So I have 3 2's, they would come out. Nothing left over, my answer is just 2, all by itself. The cube root of 27, again, I'm going to break 27 down, looking for all of my prime factors of 27. So I have the cube root of 3 times 3 times 3. In order to come off, I must have a set of 3's, 3 of them. And the 3 can come off with nothing left over, so there's nothing up under my radical. My answer is just 3. Just like before, I want you to get rid of this negative, I want you to bring it out, and only if this is an odd number. So this becomes -1 times the cube root of 125. What happened if that's in the square root, the 4th root, the 6th root? It would again be an imaginary answer. So let's break 125 down. So maybe I started out with 5 times 25, and 25 becomes 5 times 5. So up under my radical, I have negative 1 times the cube root of 5 times 5 times 5. It's a perfect cube because I have 3 5s and nothing left over. Don't forget to multiply that 5 by that negative 1 that's already out there. So this answer should be negative 5. Not all numbers are an expression have an exact cube root, just like not all of them had an exact square root. If a number is not a perfect cube, then you still may be able to simplify it. And remember, when we simplify, we are not using decimals. So the first thing we're going to do is find our prime factors. Circle our triples. 1 representative of each triple comes out of the radical sign. Any numbers left over stay under the radical sign, and simplify as much as possible without turning it into a decimal. So the cube root of 16, I'm going to find my prime factors first. Okay. So for a cube root of 16, I have 2 times 2 times 2 times 2. In order to come off of under the radical sign, I must have a set of 3. So I have a set of 2's. The 2 would come off the bus, making it 2 times the cube root, and this 2 would stay up under the bus. Don't forget to write this 3 here. Without the 3, you're telling me you took the square root. The cube root of negative 24. Okay, let's get rid of that negative, bring it out, and we can only do that because that's an odd index number. Negative 1 times the cube root of 24. And then find your prime factors of 24. So maybe you guys started out with 3 times 8. Maybe you started out 4 times 6. We don't have to start with the same 2 factors. We must have the same prime factors at the end though. So for my negative square root of negative cube root of 24, okay, I have one set of 2's that will come off the bus, but don't forget there's already a negative 1 out there, so I'm going to multiply them together. Negative 1 times 2 would make this negative 2 times the cube root of 3. Again, do not forget to write your index number of 3. Without the index, you're telling me you took the square root, and that answer would be incorrect. The cube root of 56, I'm going to write here to give myself a little bit of room. So maybe I started with 8 times 7, because 8 times 7 is 56. You may notice, hey, we already know that 8 is a perfect cube, so we're going to be able to take that the 8 out and make it a 2, really. But let's go ahead and show the work, just in case we don't see that. We can always just find our prime factors. Okay, so we got 2 times 2 is 4, 4 times 2 is 8, 8 times 7 is 56. I'm taking the cube root, so I can bring out a group of 2's, and then the 7 needs to stay inside. Okay, so 2 times the cube root of 7. 2 times the cube root of 7. Okay. If you would take a moment and pause, complete your turn sections numbers 1, 2, and 3, and then take the time to come back and check and verify that your answers are correct. Okay, so now let's check our answers. Number 1 should be 4. Number 2 should be negative 2 times the cube root of 4. And number 3 should be 3 times the cube root of 2. Okay, hopefully you did a marvelous job on that. Okay, thank you very much. So let's get ready to do some classwork today.